think big, okay? And if you do bad in certain exam, or if you get low grade, that doesn't the end of your life. Life is big. You have only one life. Even if someone tease you or someone try to mock you, just ignore those people, because there are less people who are happy with your success and more people who are happy with your failure. So ignore all the people. So what I'm trying to say, it means that when I'm making it more efficient energy storage, I need to store my energy in this certain volume. I cannot make it bigger. I cannot make my battery so bigger that my phone becomes a laptop. Okay, so it means that the condensing energy at a certain volume is more important for industrial, for real life application. That is the time when you can identify who is your real friend. Failure is like a filter, like you use filter to clean all dirty things. Some of the Da Vinci lost node, people found it, and they found that Da Vinci thought about thought about gravity even 100 years ago. Newton thought. Even before Einstein, he thought about relativity. So I'm just following my childhood passion, and I think that's what everyone should do. Do what you love and love what you do, instead of following the crowd. So what I feel that, when I'm studying something in one subject, this can be applicable also other subject. Someone studying, let's say, how bridge fail, or how something breaks. That knowledge, people are applying now in biology, how bone breaks.
Hello students! I hope everyone is doing well, isn't it, sir? Or else, if you are feeling a bit low esteem or unsure about things, you are in the right place, because today we have a very special guest with us joining, who will share some motivational facts and insights from his own life experience to help you gain clarity on your life goals as well. He is also an AI researcher, and his work is mainly focused on energy conservations. But before we delve into our guest research work, let me first pose a very important question that addresses a serious global concern. And the question is, how many of you are aware of the pressing issues surrounding energy conservation? How many of you have ever thought about the upcoming lack of energy resources in the next few years? On top of that, the Russia-Ukraine war has directly influenced the energy industry, But without delving into the conflict itself, I am trying to convey is, the world is facing a big energy crisis, okay? And as a result, companies like Tesla, a tech giant, and various other automotive industries are swiftly making moves to dominate the electric vehicle market, or in short form you can call it as an EV market. Now when we talk about the concept of preservation, it implies a certain need of specific storage facilities, right? Or a device that is capable of storing energy for a certain amount of time. The effectiveness of such device depends on its capability to store energy for a longer period of time, isn't it, sir? Now, the question is, what type of material should be used in its composition that plays a crucial role in creating that device that can effectively store energy over a longer time frame? Let me give you a common example. How often do you charge your mobile phone? Maybe once a day or once in 2 days? Regardless of how frequently you use your phone, after a while you have to put it on charge, right? That's because the battery of the mobile can't store energy for an extended period of time. Now, imagine the invention of a battery. It is so powerful that even if you are a heavy user, a very frequent user, but you wouldn't need to charge it for at least a month. Wouldn't that be a miracle? Yes? Now think about the possibilities if it is possible to invent such battery and then assemble a huge collection of those batteries. Might even power an airplane, right? Intriguing, isn't it, sir? Does this spark your interest? Okay, so without any further ado, let us begin our today's session. So, thanks, Dr. Dibakar, for joining us today. We are looking forward to engaging in several discussions about your research, future research directions, potential vacancies in your group, and many other topics. So, to begin with, could you kindly share your academic and professional journey from your UG days to where you are today as an associate professor? And with this, I also have an additional query that given your engineering background, was it your motivation to become a faculty member, considering that many individuals typically pursue corporate jobs?
Yeah. So, first of all, thank you so much for giving me opportunity to talk at your esteemed channel. I saw your videos, all are amazing. So I'm very honored to speak with you today. Yeah. So I was born and I grew up in a remote village in the North Bengal, not part of West Bengal. And since my childhood, one man fascinated me, and he is Leonardo da Vinci. So when I was a kid, I think it was around 2000. I read about him in a Bengali newspaper. I think it was his birthday, and I saw that he's the one man who did almost everything. He studied civil engineering, he studied astronomy, he studied anatomy, he designed bridge, he designed dam, and of course, who doesn't know about his Mona Lisa painting and other things. So I was fascinated by him, and I wanted to follow him, and he became my role model. I was obsessed with him. So I wanted to do exactly the same thing. And so if you see my academic background, I had my undergrad in civil engineering, then a master's in structural engineering. Then I went to Europe, in France and Spain, studying computational mechanics. I also worked in an electrical company for 6 months in Paris. And then I went to the Brown University for my PhD in solid mechanics, and I had a minor in chemistry and physics, where one Nobel laureate was my qualifying examiner. So, and then I also worked in material science department in the University of Pennsylvania. And then I went to Stanford for postdoc in mechanics and computation, and then came back here at New Jersey Tech for faculty in mechanical engineering. So this is my long journey in the three continents, in many countries. So throughout this journey, I studied more about Da Vinci, and so one of my motivation, the question that you asked me, that given engineering, why this faculty? So after my postdoc in Stanford, I got a job in Tesla Motors, and then I don't want to reveal the what salary they gave, but then I ignored that, and I came to choose to join academia. I say with significantly lower salary. Okay. And because I always wanted to teach, teaching is my passion. And I always wanted to write books. From my childhood, I wanted to write books, because whatever I'm thinking, unless I write it, people will never know what I'm thinking. So, and as I said, I'm fascinated by Da Vinci interdisciplinary research. So then I came to New Jersey Tech, and then I realized that writing books takes a lot of time. I need mental peace. And when you are in tenure track, you have the pressure to bring funding and do a lot of things. Otherwise, you'll not get tenure. So I thought, let me wait, let me finish my tenure track and let me promote it to associate professor first, and then I can write peacefully. Okay. So this is my motivation, and I always wanted to be a teacher, and I love teachings. And as I said, so from my childhood, my main goal was to write books in various fields. So I'm just following my childhood passion, and I think that's what everyone should do. Do what you love and love what you do, instead of following the crowd. I think that's the problem with most kids, especially in India, as they just follow the crowd. Or everybody doing this thing, I have to do this thing. No, just follow your, what your heart want, and that's it. So that was my, short summary of my journey.
Thanks, Divakar, for sharing such an insightful journey and giving such an insightful experience. So, I noticed that you are also writing a book, The Interdisciplinary Nature, where you aim to explore how different school subjects are connected. For instance, the Leonardo da Vinci, as you mentioned, who was your role model from your childhood, and who was itself a very talented person, live during the Italian Renaissance period, and 17th century talented mathematician Leibniz, who also made significant contributions to various branches of science. So this suggests that there is some interdisciplinary connections between different branches of science. So is this what you are trying to explore in your
Yeah,
books?
that's a very good question. So what I believe that education is like a pyramid. I don't know whether you can see this thing. So this is the pyramid that I'm going to put in my books. So I believe that, so education is like a pyramid, and more someone study different subject and they keep going on top of the pyramid, and that's why people like Leonardo da Vinci or Leibniz, to give other, or our own Jagadish Chandra Bose, and the people like them, and they were like top of the pyramid because they studied different subjects. And what I feel, as I said, my background is in a different field. So what I feel that, when I'm studying something in one subject, this can be applicable also in other subject. Someone studying, let's say, how bridge fail, or how something breaks, that knowledge, people are applying now in biology, how bone breaks, or how you are someone studying impact, impact of something on some building. Then same knowledge can be applied, when there is a head on collision or something impact on my brain, how this, so there is a connection of different subject. Now in my research, let's say, I primarily work on mechanics of energy storage material. So in energy storage, there is a lot of coupling of mechanics and electrochemistry. So how because of chemical reaction, mechanical properties change, or how because of, if I take some material and I pull it, how its electronic properties will change or chemical properties will change. So it means there is a coupling of mechanics and then electronics or other properties. So similarly, there is a coupling, or there is a connection of different subject. So I want to explore that, if I study one subject, how can I take that knowledge and work with the people of other subject to solve a problem where interdisciplinarity or interdisciplinary ideas is very much needed. There are many fields like energy storage, even many fields in the biology or other fields. I think the people from different background need to come together and solve that real life problem. And to give an idea, that interdisciplinary thought, again, I going to Da Vinci. So I was reading, actually yesterday I was reading an article that the last year there is a some of the Da Vinci lost note, people found it, and they found that Da Vinci thought about thought about gravity even 100 years ago. Newton thought, and actually, and his writing was lost. And then I saw the last year one, someone wrote that paper, and he did some experiment where he tried to calculate the gravitational constant. Even before Einstein, he thought about relativity. So I'm trying to explore. So my book will explore first all these genius people who did interdisciplinary thought, and then my book will explore how concept of one subject can be applied to other subject, how different subjects are correlated. Okay, so and then we also call this, we give a lot of different name. Like I recently wrote a paper where I call it like electromechanochemistry or electrochem-mechanics. It's like electrochemistry plus mechanics, and some people even bring magnetism, electrochemo-magnetomechanics, electrochemistry, mechanics, magnetism, so these are like a new terminology where I'll explore how different subjects are inter.
So basically, you are also trying to bring all those information which was not even available before. As you mentioned that last year you have.
Exactly, exactly. I'm also digging all this history, So I'm studying also Da Vinci's notebooks, which were recently found. I'm pretty sure that 99.99% people don't know that that before even Isaac Newton, there is someone Da Vinci who thought about gravity because his note was lost. Even theory of relativity, and there is a YouTube a web series called Genius. It's on Einstein. Even during the Einstein mentioned, and then he was in his patent clerk office. Then Max Planck assistant came and told Einstein, how did you do that thing? And then Einstein acknowledged Da Vinci. So oh no, Da Vinci thought about it, but I have given a good formula on it. So he acknowledged Da Vinci when Max Planck assistant asked him. So even Einstein even acknowledged that Da Vinci thought about it. Okay, so So these are the thought that I'll write in my books. So the book will explore everything, science, engineering, medical science, how everything is connected. So this is like my childhood dream project, that I'm now exploring.
Hope to finish that book soon, and I hope that it will be a very good books to read, and maybe for the students who are curious about science to learn more, because only when you know the history of science, the science became more interesting.
Yeah, exactly. Yeah, we get more motivated also. Yeah.
Okay, so I see that you have also worked with high school students, and they have been published paper as an interns, so which is quite new to me. So I'm asking about this, that this suggests that the awareness of research is increasing, which is quite true among high school students as well, and the trend is growing. So what approach do you suggest for those who are interested in pursuing research but they have very limited resources?
I don't know about other country, but in United States, I think there is a program in New Jersey that high school student in class 11 or class 12, they can work with university professor, and they can show their work to their high school, and high school allow them some certain time to go to the university and work there. So there is a program here. And also during summer, we have a lot of scholarship opportunity where high school student can come to university and work here. So I don't know whether these kind of things are there in India or other countries, but even if it is not there, my suggestion to high school kid, now internet is available, in a cheaper price. When I was high school a student, I didn't have a phone also. Now student have that. So my suggestion is that, if you find interesting on certain subject, find nearby universities who are those professors working in that area. So if you like programming, see who are those in nearby university, any professor is working in there. If you like mechanics or physics, whatever, and contact that professors and email them, and or tell your parents that I want to work with this professor, can you connect them? So, and you may not believe that in lot of cases parents email me first, okay, that my students in class 11, 12 do have a vacancy, or can you guide him or can you guide her. 50% cases actually the parents email me. So the student can tell their parents that I want to work with some university professor, this professor, can you contact him? And then go to the professors and email them, and request the professor to organize a Zoom meeting. And then professor, I'm sure most of the professor will be very happy to guide. Or if the professor don't have time, in some cases, to be honest, I don't get time. I plug my PhD student with the high school kid. And my PhD student, they love it because they learn how to mentor the kid. But occasionally I also see what are they doing. So I think yeah, if the professor don't have time, they can plug their PhD students and these things. Of course, I don't expect student to do very hardcore technical thing from the beginning. So a lot of patience is needed from the professor side, because to the high school kid, they need to learn a lot of basics and other things. But step by step, as you mentioned, one of my students came here, and he initially came for 2 months, and then he was studying atomistic simulation. She fell, yeah, she was a female, so she fell in love with this thing. So even after that period is over, she continued, and she kept coming to university after her school is over. And I saw a lot of potential, and I started mentoring her, more and more. And then she worked 6 8 months, and she even published a paper. Not just paper, she even went to a conference, international conference in Boston. And I think I put her picture in my website also, and because that's so special. And I think she was probably the only high school kid presenting in a conference where PhD students are presenting. And a lot of people are coming there to, what is this kid doing here? So she was probably the youngest, so the participant. So what I'm trying to say is that yeah, high school kid not just research, they can even see whether they can go to conference and present their work. And so for that, they need to be little outgoing, and they need to contact the professor, and they tell their parents, please contact that professor. So, and I'm sure that many professor will encourage them, and they can contact me as well. I'm always happy to.
Okay, thanks Dibakar for sharing this. Let us now discuss about your research, as I see that your primary work is mainly focused on energy storage. which is really a concern in today's world. Could you please share about the research, about your current research, that what is this next gen energy storage? And currently AI implementation is also becoming a trend. So how you are integrating these two things? Could you please share some details on this?
Although I've been working on different areas, mechanics of nanomaterials, the nanomaterial for biological applications, and then I work on mechanics of energy storage. But my primary work is now energy storage, as you say. So I think the energy independency is not just US, but as you see, the India government also tells people of all countries, they are saying that energy independent, we need to be energy independent. So what happened, let's say, during the Ukraine-Russia war, the gas price here was like over, I think it's $7 per gallon or something like this. So why is that? Because US is dependent on other countries for this energy and for the oil, so that's why there is a people are focusing more on these EV, electric vehicles. Also on environmental issue, I think the electric vehicle, we say that better than the petrol engine cars. But for the electric vehicle, what you need, battery is more important. So that's very important. So unless you have these good energy storage things, then forget about electric vehicles. And people have been talking about battery powered aeroplane and everything. So that's like a long shot, but whatever. So it means that the energy storage has a lot of potential. And forget about this now, this the car. For the timing, we can even think about our this phone. Once you charge our phone, let's say my phone, it lasts for 4 or 5 hours. What if I charge my phone and it lasts for 1 month? Then I can go for vacation without my charger. So what I'm trying to say, so we need material that can store energy uh, efficiently at a low cost. Also, that material need to be environmental friendly. So nowadays, when you store energy, in the energy storage river, there is a element called cobalt, and cobalt is environmentally very toxic. And most of this cobalt comes from Africa, in country called Congo, where a lot of child labor is forcefully put into work. So even recently Tesla and a lot of other companies, they came under fire because of this human rights issue and other things. So people are trying to make energy storage device that is cheaper, that is more efficient, that is environmentally friendly, an energy storage system that doesn't use all this toxic element. Okay, so those are some of the criteria that we are working on. Can we have energy storage system where you can avoid toxic element, where we can avoid high cost, where we can have energy storage system so that I can charge my phone and it will last for 1 month. Okay, so these are some of the issues that we are highlighting, and I don't want to make it very technical, but I just want to highlight one thing, that there is a gap between academic research and industrial research. So in academic research, people, because people are more in rush in publishing paper, so we just take a material and see that it is very good and publish paper. But thing is that there is something called gravimetric capacity and something called volumetric capacity. Let me explain. So gravimetric capacity is energy per unit mass, and volumetric capacity, energy per unit volume. Okay, now I don't want to make it too technical. So it means that I have given this volume, I want to store more and more energy here. So it means that I want more volumetric capacity. Okay, so why now for industrial application, this volumetric capacity is more important. The reason is that, let's say iPhone, this is iPhone, let's say 14. If you compare iPhone 10, it is little bit heavier. Okay, but people still buy it. It was sold in a record number. Even the iPhone 16 is little bit more heavier, people will still buy it. Okay, but if the iPhone is little bit bigger and you cannot keep inside your pocket, then it's not a phone anymore. It's now a tablet. People will not buy it. So what I'm trying to say, it means that when I'm making it more efficient energy storage, I need to store my energy in this certain volume. I cannot make it bigger. I cannot make my battery so bigger that my phone becomes a laptop. Okay, so it means that the condensing energy at a certain volume is more important for industrial, for real life application. And that's why a lot of academic research is lacking. So we are focusing on that thing also. we have to condense energy at a certain volume so that this is implemented in a real life device. Okay, so this is some of the in a non-technical sense I'm trying to explain. So we are working on energy storage that is economical, that is cheaper, that is lightweight, that is environmental friendly, and also that can store energy in a certain volume. We can have higher volumetric capacity. And also we are also working something called beyond lithium batteries. So most of the existing energy storage is based on lithium, but lithium ion on earth is very limited, and it is projected that after some years it will the lithium resource will go down and down. So we are also working on other element like magnesium, calcium, and other beyond lithium energy storage systems. So these are some of the things we have been working on. And coming to our AI, so AI is very important here, because what we do is computational research. There can be millions of possibilities, in fact infinite possibilities of materials. Now I cannot take all material one by one and I can do my computational and I can test everything which material is good for me, because there is infinite possibility, and experimentalists cannot do that anyway. So, and only doing computation, only doing like say first principle calculation and atomistic simulation is impossible. So that's why we need this AI here, and that's why AI for energy storage is the next big things. And a lot of people are working on it, and in a lot of companies now, Google, IBM, so they are all jumping on these fields now. Okay, so idea is that we train all these materials using first principle atomistic simulation. Then we have this enough data, and then we train our AI model so that AI can automatically predict what might be the new materials that can be more efficient. Okay, so this is how we are also implementing AI, but there are a lot of challenges here. So because to have a good machine learning output, we need good input, we need good data, and to generate the data on these atomistic materials, we need atomistic simulation, which is very computationally very expensive. Okay, although we have some database where we have properties of different materials, but probably you saw that we are working also heterostructure. It means that combination of one material with other material, combining two materials, we call it heterostructure. So but the database on heterostructure on this composite system is not much. Okay, database on individual material are there. There's something called material project, but database on composite system is not much available. So we are trying to generate more and more data. We are trying to study more and more composite structures, or we are studying more material whose information is not available. These are computationally very expensive calculation. But we are working on it, generating data, and then using this data to train our AI model. So it takes a lot of times. Sometimes my student get annoyed. It's very expensive. We don't get paper very quickly. And then I motivate them. Imagine you are the first one working on it. So you are doing something very unique. So think about it. And then they get motivated. Okay, so this is in a nutshell what we are working on.
So I have one question here, that is the battery that are used on say Tesla car or in mobile, so are their structure same? I mean the compositions are same, or they're different?
But that's a very good question. Yeah, fundamentally the composition is very same. If you see the Tesla car, is not inside the Tesla car, it's not 700 or 800 small battery assembled inside the car. Okay, so it means, and fundamentally the structure is same. The battery structure, the energy storage system structure fundamentally is same. The same battery that we are using inside the car, same battery inside this thing. So the fundamental science that is operating this energy storage system there and there, that is the same. So during my PhD at Brown University, I worked on a new material called graphene. An inventor of graphene even got Nobel Prize in 2010. So I showed that if I use this graphene and change the topology or surface configuration of graphene, it can be efficiently used in energy storage. I can have an energy storage system with 5 times more capacity. But then I showed this to Tesla Motor. They invited me in their headquarters in California, and they told it's not so simple. What you did kind of academic research is it will take a lot of things to implement in industry scale. When I told them it is 5 times more is kind of gravimetric capacity. I showed them energy per unit mass. But to implement that for real life application, they will need a huge volume. So it means their existing car size has to be much more. So for industry, they need to store energy at a certain volume. So that's why I'm saying that, and I learned it when I went there, when I talked to industry people. So that's why the people in academia who wants to see their research for industry application, they should talk to industry. They should talk to people in industry, what exactly they need, what need to be done, so that research can be translated in real life application. So that's why industry academic interaction is very important in my point of view.
Okay, thanks, Professor. So, as you have mentioned that you are also working on graphene silicon and graphene tin combinations. So, with this, I have one question: that can the graphene silicon or graphene tin combination be applied into other technologies or industries beyond solar cells?
Yeah, that's a very, very good question. I think one Nobel laureate in physics, his name is, I think, Kramer Herbert something. During his Nobel Prize award, he actually got Nobel Prize because of this composite structure, implementing composite structure for electronics application, and he coined the term interface is the device. So interface comes when you put different materials together. Okay, so this interface, let's say composite systems, it can be applied almost in everything, because strength of one material and strength of another material can be less, but when you combine them, maybe combined material can have bigger strength. Okay, so then it can be applied aerospace, building applications. It can be applied in the military application, in everywhere. This composite structure, there's a huge research on composite structure. So in composite structure, people are studying at a nanoscale. How can I integrate? How can I change the electronics properties? Graphene can have certain electronics property. Let's take another material. Let's call TMD, another 2D material. It can have certain electronic property. But when I combine them, the combined structure may have another electronic property, another magnetic property. So that can be applied in nanoelectronics, electronics application, or that can be applied to some other gadget. Okay. Similarly, in medical science also, we can apply a lot of composite structures for medical science application, because their biological properties might be different. Okay. So I had some studies on how to use 2D material and their composite for drug delivery purpose. So I think this is a huge field. And now I want to bring your AI here. So now if I want to combine one material, another material, how many possibilities you may have? Infinite possibilities. Okay. And there AI comes into play, because you cannot take one material, another material, and manually study all the material. Then, so even in your like billion years, you cannot finish it. That's why AI for interface, studying the interface system, studying the composite systems, it has a huge potential in future. And also, as I said, when you study nanomaterial, you need the database to train your AI model. I have database now for individual material. I have database for graphene. I have database for, let's say, TMD. I have database for other material. But when you combine them, their property is different. Okay, I need database where I have this heterostructure, or let's say composite structure database. Then I can use that to train my AI model. But that database is lacking now. That's what we are working on. So this is a huge potential.
So based on that, what is your plan then? I mean, are you going to sell those data, or you are going to use only for your experiment?
No. That's a very good question. I don't want to sell the data. Everything I'm doing will be open source, so that will advance knowledge, that will help other researchers to validate my data, to use my data for their work. I have no plan to commercialize my data. So everything open source. I want people to come together, work together, and make this world as a better place.
So as you have already mentioned, that industry collaborations is very essential for advancements of research, but you do not have any plan for commercializations of this technology.
I'm not going to industry and working really, but I am actually, so let's say industry want to test some new material. Now, what they have to do, experiment on that material. Okay. But to do experiment is expensive. So they tell that we want to test this material. Can you computationally predict that whether it is good? So currently I'm working on another material called niobium tungsten oxide. It's, let's say, oxide material. Let's for simple. So oxide material, so these are special material. It has a lot of pore inside. And when you pour inside, it's good for energy storage, because in energy storage, iron will come, it will stay, it will get attached in that pore, so a lot of energy can be stored. Now, doing experiment on that for industry, it can take a lot of money. So what I'm doing computation. You can say virtual experiment on computer, and I'm giving them idea. Okay, among, let's say, this 10 material, this material might be good. So while doing that, I'm also generating a lot of data. Then I'm going to use this data to train the AI model, which my student is doing. Using the AI model, I'm going to test 1,000 other oxide material, among them which can be the very good materials. So that's why I'm giving the input to my industry colleague, to my experimental colleague, saving their time, saving their money, and telling them which might be the optimized material. And they will then work on that material to proceed further for commercialization or other research purpose. So that's why I'm collaborating with them. That's why I'm giving my input to them.
Yeah, I think it's a very good mutual collaborations that industry are also having saving their money with the collaborations with academic research, and you're also getting lots of insightful experience, and you're also creating your data with the collaborations of industry. It's a mutual collaborations benefiting both sides.
Exactly. That's why I think a lot of industry, they are hiring also. They're not just collaborating with the university. They are even hiring a lot of computational people. My one of my PhD student working in IBM. I have another PhD student working in other companies, and so they are hiring also a lot of computational people. So they have now separate R&D section where they have a lot of computational people. So they are focusing on also computational side.
Everything is not possible to do the experiment in hand. Then it
Yeah,
will take lots of time and
lots of
lots
money.
of money.
Money is very important. Yeah.
Okay, thanks for sharing such an insightful research. I hope many of our viewers will be get interested with this.
Thank you. Thank you so much.
So, could you please share about your current projects and vacancies about interns, PhDs, or postdocs?
Yeah, so currently I'm mainly working on energy storage and discovering new material for next generation energy storage. I'm funded by National Science Foundation and some other agencies. So mainly the different scientific aspect that I discussed. So currently I'm hiring. I recently hired actually two PhD student. I have another PhD student coming, and I have one postdoc opening. But internship, I always encourage high school student and undergrad students to write to me, and I can always happy. I'm always happy to guide them for various project.
Okay, thanks for sharing this information. So, we are going to end these sessions today. It's really very nice to talking to you. But before ending, I used to ask these questions to all of my podcast guests that what are the guidance for students you want to share uh, for mainly for school students or B.Tech or fresh PhD who wants to join thinking about PhD. So, what is your advice for them?
First thing I have to tell one thing, because I recently see a lot of news, students in India committing suicide for getting low grade or some things. I have to tell all the students that you will be remembered in this world for what you do in your life. No one will remember you for your grade in school and college. So have a bigger vision in life. That in my life I want to do this. I want to write these books. If I see after 20 years I want to do this. So when I leave this world, people will remember me for this work. So think big, okay? And if you do bad in certain exam, or if you get low grade, that doesn't the end of your life. Life is big. You have only one life. Even if someone tease you or someone try to mock you, just ignore those people, because there are less people who are happy with your success and more people who are happy with your failure. So ignore all the people. You see the horse race. When you in the horse race, the horse, they put something so that horse only see in the front, the horse doesn't see in this way. So be like that horse. You set your goal, just be like this. Don't see others, what other talking about or thinking about you, and chase your goal. Do what you love and love what you do. Don't follow the crowd. If you love mechanics, study mechanics. If you love computers, study computer. If you love medicine, go for it. If you love literature, study literature. If you love making film, study filmography. So do what you love. So listen to your heart. Since my childhood, I know that I love Leonardo da Vinci. I want to engage in interdisciplinary research. I want to write books. This is my goal in life, and I did exactly these things. I never cared what people are thinking about me. So that's things. Other thing, be outgoing, talk to people, because it's very important to get advice, it's very important to get information. So when I went to Europe, I got European Commission fellowship, and I got that information from one of my senior. If that senior was not in my life, I didn't know about it. Even when I applying to US for PhD, I wrote to many professor. During that time also, my senior told me that these professors, this university, they are good, you should write to them. Of course, I also search by myself. So what I'm trying to say, be outgoing, talk to people, and of course watch these YouTube channels. That's is very important. And write to people, and get the good guidance. Environment is very important. And I'm telling you, the founder of Dropbox, Drew Houston, when he was at MIT, he told one thing, that it's not sufficient to be a very good, or it's not sufficient to be brilliant. It's very important to be surrounded by smart and inspiring people. That's very important to flourish your creativity. So try to surround yourself with people who encourage you, who will be with you when you fail. Okay, so, and always remember that during your long journey you may fail, but one failure doesn't decide your life. Okay, so when you fail, be strong. And when you fail, if someone criticize you, mock you, okay, just ignore these people. As I said, the failure is the time when you can identify who is your real friend. Failure is like a filter, like you use filter to clean all dirty things. Use your filter like a filter, see, identify your real friend. And use your failure as a learning process. I think someone said we never fail. Either we succeed or we learn. Okay, so we'll never fail. So when you fail, just learn from that failure. To give my latest example, I recently got very prestigious National Science Foundation Career Award in my third attempt. My first two attempt was a failure. But that doesn't mean that I leave this thing. I learned from that failure. Okay, so this is some of my advice. Be outgoing, talk to people who are successful, who can guide you. Talk to people, okay, and get good advice. Listen to your heart, okay. So, and always keep in mind that you will be remembered for what you do in your life. Nobody remember who was the first boy in Albert Einstein class. Albert Einstein never stood first in his class, okay, but people remember Albert Einstein. As long as earth rotates around the sun, people will remember Einstein. Nobody care who was first boy in his class. So what I'm trying to say, have a bigger vision in life, okay. Have a bigger vision in life. Don't allow one or two failure to judge you. Don't, or if someone judging you, okay. Be strong. Use your failure like a learning process. Keep moving, and keep going, okay. So I have a quote: life goes on irrespective of ecstasy and agony. So life goes on, so keep moving, and always feel free to contact me. I'm always happy to help.
Okay, thanks, Professor, for sharing such important advice to our fellow students. And I wish you all the best for your future endeavors, and have a nice day. Thank you.
Thank you so much for inviting me. It's a great honor to be a part of your channel. Thank you so much.